Touch our atmosphere. Right now, with every breath you take, carbon dioxide molecules that have increased 50% since the Industrial Revolution enter your lungs. This isn't just a statistic, it's the physical reality of our planet's most urgent crisis. Climate change isn't just warmer weather, it's the disruption of Earth's energy balance. Every second, the extra energy added to our atmosphere from human activities equals 4 Hiroshima atomic bombs. Where does this energy go? 93% is absorbed by oceans, making them hotter and more acidic. The science is unequivocal. We're not talking about weather, but climate. Since 1850, 9 of the 10 hottest years have occurred after 2010. Carbon dioxide levels have reached concentrations unseen for at least 3 million years. How do we know? Ice cores, tree rings, coral records all tell the same story. Human activities, especially burning fossil fuels and deforestation, are the primary drivers. Other greenhouse gases, like methane from livestock and oil extraction, and nitrous oxides from agriculture, also contribute. But this isn't just about temperature. We're talking about systemic change. Ocean acidification makes it harder for shelled creatures to build shells. Melting polar ice alters ocean currents. Permafrost thaw releases more methane. These feedback loops trigger more change, accelerating the process. For example, when white ice melts, darker ocean absorbs more solar energy, causing more melting. This is a positive feedback loop, and at least 15 major ones have been identified in our natural systems. The biggest misconception? Thinking change is linear. Climate systems have tipping points, thresholds of irreversible change. Amazon rainforest desertification, Greenland ice sheet collapse, Atlantic Ocean current system collapse, all could be triggered between 1.5 degrees Celsius and 3 degrees Celsius. We're currently at 1.2 degrees Celsius. What science tells us is simple. Every tenth of a degree matters. The difference between 1.5 degrees Celsius and 2 degrees Celsius means hundreds of millions more people exposed to drought, hunger, and extreme weather. No panic, just physics. Climate change is complex, but the solution is simple. Reduce carbon emissions to zero. How? 3 main pathways. 1. Decarbonize our energy systems. 2. Protect and expand natural carbon sinks. 3. Remove carbon from the air. Good news. The technology is ready. Renewable energy is now cheaper than fossil fuels in many places. Solar power costs have dropped 90% in the last decade. Wind power is the cheapest new energy source in many parts of the world. But energy transition isn't enough. Full system transformation is required. Electric transportation. An electric car's lifetime carbon footprint is half that of a gasoline car. Green steel and cement. Hydrogen-based production could reduce emissions by 95% compared to traditional methods. Agriculture. Regenerative farming can store carbon in soil while increasing yields. Food system. Shifting to plant-based diets could reduce food-related emissions by 70%. The most overlooked solution? Nature. Forests, peatlands, mangroves, and seagrasses are excellent carbon sinks. The Amazon stores 2 billion tons of carbon annually. But we can't just protect, we must restore. Large-scale ecosystem restoration initiatives aim to plant 1 trillion trees by 2030. Oceans, seaweed farming, and mangrove restoration both capture carbon and support biodiversity. What about carbon capture? Direct air capture technologies remove CO2 from the air. Currently expensive, but costs drop as we scale. More interesting, enhanced geological storage. Injecting carbon into basalt rocks, turning it into stable minerals for thousands of years. But caution, this doesn't replace reducing emissions. only complements it. The most crucial puzzle piece: energy storage. Solar and wind are intermittent solutions. Improved battery technologies, pumped hydro storage, green hydrogen, even gravity storage systems. The International Energy Agency states the pathway to net zero by 2050 exists and would grow the global economy while reducing energy bills. But technology isn't enough. We need policy. Carbon pricing implements the polluter pays principle. Subsidy redirection. Global fossil fuel subsidies total $11 million per minute. We could redirect this money to clean energy and finance. Sustainable investments now exceed $35 trillion and are growing rapidly. We're now choosing between two futures. First scenario: current policies continue. This leads to 3 degrees Celsius warming by 2100. Consequences: sea levels rise 1 meter, coastal cities flood, agricultural productivity drops 30%, food crises become widespread, 99% of coral reefs die, hundreds of millions become climate refugees, economic losses reach trillions annually. Second scenario: achieving Paris Agreement goals, limiting to 1.5 degrees Celsius. What this means: halving emissions by 2030, reaching net zero by 2025. This is ambitious but achievable. Requirements: reducing coal use 90% in 10 years, stopping deforestation, reaching 100% electric vehicle sales by 2035. Cost: 2–3% of global GDP. The cost of not doing it? Much higher. What about just transition? Climate justice is essential. Rich countries are responsible for most historical emissions, while poor countries bear the heaviest burdens. Solution: developed countries providing financing, technology transfer, and capacity building. Mechanisms like the Green Climate Fund exist, but are funded far below commitments. Here's the most inspiring part: climate action doesn't just prevent disaster, it builds a better world. Clean air prevents 7 million premature deaths annually. Green cities offer higher quality of life. Circular economy eliminates waste and increases resource efficiency. Biodiversity conservation supports ecosystem resilience. Future technologies: fusion energy promises limitless clean power. Artificial photosynthesis could turn sunlight into fuels. Geoengineering, like stratospheric aerosol injection, is proposed as controversial emergency measures, but side effects are unknown and don't address root causes. Ultimately, this isn't a science story, but a human story. Every ton of CO2 matters. Every choice matters. Science has shown us the way. Now we need the will. Climate change will be the defining challenge of our era. We will either adapt and transform or suffer the consequences. In our next episode, we explore astrobiology. Are we alone in the universe? Subscribe and turn on notifications. Remember, saving the planet means preserving not just glaciers, but hope for future generations.